Hello, well, good afternoon. Welcome to Experience Power, brought to you by Power Magazine. Before we begin this session, I want to take a moment to thank you all for attending and to encourage you to always network with your colleagues, visit the exhibitors and sponsors, get as much out of this event as you possibly can while you're here with us this week. We know we can't be together in person, so we definitely want to encourage you to try and network as much as possible while you're at the event. And the more you network, the more the more exhibitors you visit, and the more sessions you attend, the better your chances at winning one of our prizes. At 4 p.m. Central today, we'll be giving away another prize. So join us to see who the winner is. We're excited to have everyone participate this week, even if it's not in person. As always, participation is key, so we encourage you to ask your questions and ask as many questions as you can. So the questions will be submitted over on the right-hand side in your question tab, and the moderator and the panelists will get to the questions as soon as all their presentations have been completed. This session is brought to you by NRG Energy Services. We are proud to have them as our sponsor of this session today.
This shop was originally designed to be a utility turbine and pump repair shop. So we've got the crane capacity, we've got the machine capacity, and we've got the experience and knowledge to work on utility-sized equipment. Many of these plants are 40, even 50 years old now, and those parts just can't be bought. A lot of our work is just fixing broken stuff and getting the unit back online as quick as we can.
Thanks to NRG Energy Services for sponsoring this session on maintenance planning. So it's a perfect opportunity for both of you to learn a little more about maintenance planning. Our moderator today is Hank Hamlin. He is on our advisory board, and he is the O&M manager at the Coronado Generating Station of Salt River Project. Take it away, Hank.
Thanks, Kim, and welcome everybody this morning for me out here in Arizona. Glad everybody could be here and look forward to having a good discussion after the presentations. And we're excited for this particular set of presentations. And, you know, when we started talking about this particular subject, it was almost a year ago now before COVID hit. One of the things we talked about in our group was the need to understand more along the lines of how to plan for maintenance, you know, preventive maintenance and outages and, you know, reactive maintenance and all these things. And so, you know, we came to the conclusion, and I'm sure everybody else feels this way too, is it's just not just as simple as putting something on a schedule. Especially in this COVID area, we've had to defer outages, as I'm sure a lot of you have in the group. And so taking the time to make sure we allow the work to be completed, you know, getting the parts here on time, coordinating the clearances or the lockout tagout requirements, verifying contractors and workers are all trained up and ready to go. There's a lot of stuff that goes into this. And so this session will hopefully provide some opportunities and some tips and strategies on how to better do that. So like Kim said, please submit all your questions, any topics for discussion for after the presentations, so we can have a good in-depth discussion. Let's move on to our first speaker is Keith Behrman. He's the Engagement Director of Professional Services at Emerson Automation Solutions. Keith's an Engagement Director and Senior Consultant with more than 30 years of experience in maintenance, reliability, and digital transformation. Prior to joining Emerson, he was the Director of Reliability and Engineering for a major fertilizer producer, leading the development and implementation of a significant maintenance reliability improvement program across 14 different locations, including continuous gas processing, mining, mineral processing, and acid production. A regular conference speaker and recognized thought leader, Keith has presented at conferences across North America, England, Australia, South Africa, and Brazil. So with that, Keith, let's turn it over to you.
Thanks, Hank. The good news is that I'm trying not to get 4 days of training and material into 15 minutes, but we're trying to get it into 20 minutes. So that extra 5 minutes is going to make all the difference today. It'll be a bit high level, but it'll give you hopefully some of the basics that we're trying to drive through with organizations around the world as we try and help people improve and see people on that journey. So let's just talk about some basics. And you guys probably understand this, but we want to make sure that we're all on the same page. So I think a lot of us are familiar with Doc Parmer has written the handbook on planning and scheduling, and this basic work identification, planning, scheduling, execution, follow-up analysis loop that goes on. One of the things that we focus a lot on in this is, the execution. We tend to talk about how do we do more work, but each of these is linked inextricably. And if we don't do a good job of any of these, then the whole loop falls down. And so we're continually working on improving these pieces as we go around. The other fundamental piece I want to talk about is the balance of work. So we spend a lot of time talking and have done in my different lifetimes about how much of what sort of work should we be doing. So basically what we're saying is 15% of our time should be on predictive maintenance and 35% of our time should be fixing the things we found. So fully half of our time is looking for problems and fixing them before they become failures. Another 15% is spent on PM tasks, so time-based inspections, oil changes, that kind of stuff, and another 15% of follow-up work. So now we're up to 80% of our time looking for problems and fixing them. And when we first started, this journey a long time ago, this last 20% used to be called reactive, and we've got better than that now. So less than 5% of our time is spent doing reactive work, and 15 or more % of time is doing requested work. So can you improve this? Can we fix that? Project support and those things. And this is where we're trying to get to. So the whole discussion is we're trying to drive to this sort of balance. So planning drives scheduling, not surprisingly, but planning is not scheduling. And one of the challenges with the English language is separating these two functions. It gets worse when you work with countries in different languages. So I have a plant in the Czech Republic I'm working on, and there is only one word for planning and scheduling. It's the same word. So we've had to use a different word, agenda, like in a class agenda for a school, to drive scheduling and explain that just so we can separate the two things. So it's not scheduling, it's not building the schedule, but without good planning, you can't build a good schedule because we don't know how long the job will take. We don't know how many people we need. We don't know who's got the crane, all of those things. We need to make sure our work plans ensure the right work gets done with the right parts, the right tradesmen and equipment. And the idea of planning is to improve tool time. So how long it takes to get a job done. And what we're trying to do is to avoid the multiple trips to Home Depot to get things that we forgot to get the first time. So that's what this is all about. Plans need to identify enough steps to be clear, but not too complicated. So we don't need to do righty-tighty, lefty-loosey planning, but we do need to say, hey, take this piece off first and do the next piece second. So for example, I changed the air filter in my Ford Focus. I know that I can take the filter out of the box once I've taken the lid off, but I cannot get the filter back in unless I pull the duct that goes into the box out because it doesn't fit. I can't do the two things at once. So I have to pull the duct out and do that. And of course, I do that once a year, and every year I forget. So, there's a classic example of I should have a job plan for that by now. But hey, do what I say and not necessarily what I do. Identify and order parts, labor, special equipment, so forth. So this is critical when we're using things like cranes and man lifts. Most sites have a limited inventory of these things. If you're lucky to have 3 or 4, as I was once upon a time, you can still get into a tangle about which crane shows up to which job. And then things like scaffolding. Do we need to scaffold? Have we got the scaffolding? And so on. We need to make sure we've got tolerances and testing. So what's the torque setting for these bolts? What is the tension setting for this belt? Simple things that drive precision maintenance that allow us to make a good repair and avoid rework. Pictures are handy in job plans. So always try and use pictures, especially if we're doing something like a piping route or, changing a specific thing. I mean, after all, when you go to the hospital and we're getting a leg operated on, they give you a Sharpie to write on your leg, cut here, not here, type of thing. That's what we want to use the picture for, because we don't always start on the right piece of equipment. And then management of change is an important thing. And I think depending on your jurisdiction, management of change is more or less rigorous. And by that, I mean, have we done a thorough review to ensure that the parts we're going to use are suitable? So I work with ammonia plants, for a long time, and you can't use brass in ammonia service because the ammonia eats it. So we need to make sure we're using the right stuff. And then finally, is the plan cost effective? So one of my things that still upsets me 15 years later is that I wrote a work order to change a light bulb on the side of a building because I was the building owner. And the planner came along, decided to change all the light bulbs on the building while we were doing it. And rather than just use a ladder to get to the light bulb, he used scaffolding. So what should have been a $35 light bulb change with $100 worth of labor turned into a $15,000 work order. And there was no authorization before it was released. And I got heck from the plant manager. And you imagine that stuff just flows downhill, but the maintenance manager just laughed at me. So it was kind of fun. So scheduling is a plant activity. One of the big hurdles that we need to overcome in our organizations is that scheduling is not maintenance. Okay, planning is a maintenance activity because we understand the job, but scheduling is not. We need to do that as a cooperative activity, and that's why, you know, in the title I said this is a team sport. We need to do it together. You know, the best example I can use is that, you know, on a soccer field, you have half the team is playing defense and half the team is playing offense. But if there's a wall between the two, you don't know where the attackers are, the forwards are when you've got the ball. You don't know where to pass it. You don't know how to move that forward. We need visibility and we need cooperation. So it's really important that we build our schedule with PM work first. We start, you know, several weeks out, load up with the PMs because we know what that schedule is. We know when that work is supposed to come up. We've done work to make sure that that process is optimized, and we want to get that in there. And one of the challenges that we get is the first thing that gets thrown out of the schedule is PMs because, man, we got a lot of stuff to fix. And my question then to the maintenance guy is, okay, would you do PM work on overtime? And he says, no. I said, would you repair the things that you didn't do the PM work on overtime? He said, for sure. So at that point, we're kind of going in circles. Why wouldn't you do the PM work? So get the PM work done. Add the corrective and request work. Integrate the work with the production plan. This is something that we see as being really important. A lot of our processes are continuous, particularly in the power industry. You know, you're producing all the time. But we are starting to shift. We're getting market outages. We're running on market supply rather than continuous base load. And those things give us opportunities to schedule work when it's convenient for us and not to drop the plant out in the middle of supper when we need to be putting all the power out that we can, or on a hot day in the deep south when you want to run all your air conditioning. So scheduling is not a maintenance activity. And one of the things we struggle with constantly is that you maintenance guys tell us when you want to do the work. And what I'm saying is that's nice, but if you're driving the car and you wake up at 5 o'clock in the morning to go to work and the car is gone because the garage came to get it to do maintenance on it, you're going to be a little choked. So you guys who own the equipment need to be driving the schedule. When do you want us to do this work? What is important for us to do? And we will make sure we're there to do it for you. So it needs to be a team activity, but who owns the schedule in your plant? This is a great opportunity for some serious discussion. Or if you're into it, pull the pin, throw the grenade, and see what happens, because this is a good question to ask. We need to get control of the schedule, so we need what coming at us. So we need to look for faults to identify issues, so we've got time to plan and schedule. So condition monitoring and non-invasive inspection allows us to do that, and forewarned is forearmed. But the basis of this, and I'm sorry if you can't read this, you're not really meant to, but the idea is that we've got a routine and we get into a routine with our schedule for weekly scheduling. Monday we do this, Tuesday we do this, Wednesday we do this, and daily scheduling, morning meetings, afternoon meetings, overnight, so on. And it's clear and it's a rhythm. And I think one of the big things with scheduling is that we need to take people out of this as much as possible. And in no way am I want to be rude to management, but we need to stop managing work and we need to let the schedule process manage the schedule so that we do the right things at the right time. So one of the things that we've got to so far is that these things are all business activities and business processes. They don't require technology. Of course, having a maintenance management system is handy, but you know, people constantly are asking us, and particularly us at Emerson, because we sell toys, is, you know, what toys do I need to buy to make my availability and improve my stuff? And I'm saying, okay, first fix your house and then buy the toys. And they go, yeah, but I want to buy toys. So, okay, you need some toys. There's no question. So we know that condition monitoring drives better performance. We know that being reactive can be 4 times at least as much more cost than being proactive. We know that because it takes time to react. You don't have the parts with you. You don't necessarily have the people, and the downtime is longer. So my favorite example of this is we had a main belt that fed ore from a potash mine to the potash mill. And the belt died on a Friday afternoon after everybody had gone home, and sensible maintenance team were all headed to the lake. So when the call went out for people to come in and fix it, the maintenance team looked at the call display and said, yeah, no, we're not going. So then they found some contractors, and then they found a spare belt, and then they got into doing the job, and they made a mess of the spare belt. So then they had to get another one. And this is not a short belt, and it's not a narrow belt. As you can imagine, it's several hundred yards long, and it's several feet wide. So the repair, instead of being done in 24 hours, took 72 and cost several $1 million. Needless to say, the vice president had a fit and picked up the phone and yelled at me, what are you doing with your reliability program? And fortunately, I am smarter than the vice president. So I said to him, well, we had 6 work orders that identified damage on the belt, and that we had asked for time to replace it. And you guys said we couldn't replace it. So don't come whining at me. I got kind of grumpy with him. He got grumpy with me. We agreed to disagree, but I counted as a victory. We knew there was a problem and we couldn't get at it. So let's identify the problems. Let's get them scheduled. Let's look at the causes. And we know that we can save considerable amounts of money on our maintenance costs. No presentation is complete without a PF curve. Hopefully you guys have seen this before, but really what we're using this picture for is to remind us that the condition monitoring tasks that we want to do while the plant is running need to be derived from some sort of thought process. So we refer to RCM and FMEA as that thought process. Now, does that mean you need to spend a lot of time doing these things because they are super intensive resource drains? Maybe not, but you do need to understand this thought process as we're picking what's the best tool to apply to this failure mode that we're trying to resolve. We need strong schedules and compliance, so we need to do this. And I've lost count of the times that I've gone to a plant and we said, well, we've got a vibration problem in a bearing, and the last time we did monitoring on that was 9 months ago. So we didn't see it coming, and it ticks me off because we know the problem is there. We should have known the problem is there. We should have identified the fault before it becomes a failure and drive that shift from reactive to proactive. The good thing about technology today then too, and modeling and machine learning and analytics, is that we can look further back along this curve before we start to see degradation of performance and see things going. So let's talk about the future a little bit and where we're going with that. This is machine learning and how we might put machine learning together. And we've started to invest quite a lot of that on our side of the fence. And we know that our customers are investing in this too. And one of the interesting things for me coming into this as an old guy, you can see all the gray hairs that I've earned, is that I thought that this was build a model, test it, and away we go, based on some engineering principles. And what I've learned is that in reality, we're looking for problems that we've had in the past, and we're looking for all of this data around that problem. And then we're looking at the data, and doing some data analytic tools that now have become more semi-automated given software. And then we're using those tools to do things like clustering. So we're overlaying sets of data, looking for commonality. We're looking for cleaning and shuffling. We're looking at events and regressions and these different types of tools. And then we are then able to see, hey, the butterfly flapped its wings in Tiananmen Square, and 6 weeks later we had a tornado in Arkansas, and the causal relationship between the two. So the best example of this I can give is a pH excursion that destroyed a cooling tower for me at a plant quite a while ago. But we were able to go through the data. We had to do quite a bit of this manually. We weren't using the same tools that are available today, but we found a pH excursion in the cooling water that wasn't very long, but it provided a corrosive atmosphere long enough that it ate the shroud on the cooling tower. And the next thing you know, the cooling tower shroud came off, hit the fan died, went through the side of the cooling tower, and we were down for quite a while. We can then take this model and test it online. We can start to run it against reality and look for the same ripples in data that we saw and give us an advanced look. The other thing we can do then is use that data to build some active root cause analysis or some failure mode charts that allow us to do some machine learning. And this is the interesting part going forward, is not that, hey, there's an alarm that says you've got a problem, but you've got a problem and here are the things you ought to be doing about it. So what does that look like? Well, it looks like this. We take a fault tree, but each of these nodes on the fault tree might be a little bit of computer programming that's a logic program that says we've got some sources of information. So these are tags. We've got some sample type data. We can add them together. We can create a threshold and trigger at this event. So we can now build this data so that we've got an alert here at this point implies that we've got an alert for the drive motor winding failure that implies that we're going to get a drive motor failure. Or even a reading in this middle layer goes both ways back and forth that allows us to take some warning and take some alert. So this machine learning is starting to capture the knowledge that us gray-haired guys have got, where we can look at something and say, okay, it's that. And we are now building that so we can start to automate that process. So where's this going then, planning for tomorrow? So we've got all of our stuff in place, so we know what it looks like. So really where we're headed to is this view of the future, and we're very close to getting there. So we start on the top left-hand corner here with pervasive sensing. So our sensing capability is improved. So we're happy about that because we sell these things. But our customers are happy because the cost of putting sensing in has got a lot lower. We can do a lot more stuff with Wi-Fi networks, so we're not running cables, and we can measure the things that we need to measure. So what are the failure modes and what is the data that we're looking for? We can combine that data with our historical data, with our PDM system, with our controls, all of those data sources that used to be written in different languages that we couldn't talk to are now consistently available to us, and we can combine them and drive into some level of predictive analytics. That analytics may take a path back, and ideally we can make some changes to our energy usage and our production settings so that we can avoid the failure. And so, by changing the pressure and rate of a turbine, we can just scale it back a little bit to get out of the problem that we're in. We can adjust and tune a valve online, make changes to our process that start to reduce the problem, or we run it through this root cause that we talked about and come up with here's what needs to happen. Then we can generate automatically a work order, and we've spent time because we've built plans. So we go back to the foundational work that we did with our planning function. We have job plans in place for specific pieces of equipment for specific issues. So we know that when we get a low flow out of a pump, that we need to replace the impeller, that we need to change the valves and so forth, and that job plan exists. That gets triggered automatically, shows up on somebody's tablet. And it's important that we talk about this just quickly, because this is not being better at being reactive, but no, we know we've got a flow degradation on a pump, and we need to schedule this over the next 2 weeks at a time that's convenient. And that can be automated, and it's starting to be. So we know we've got the permits are generated automatically, the team is notified, the kits are generated out of stores, and away we go. And this loop starts to become more and more automated, and we're now taking people out of the process, which in the end makes us more consistent. So key takeaways from this. Make sure your improvement program is built on a strong foundation. So again, I want to reiterate, a lot of folks are looking for a magic bullet. As Hank said in the intro, I've had a good chance to talk at different places around the world, and it's interesting the culture that exists in different countries. So definitely in the US, Canada, we are keen on silver bullets and tools that we can apply to our problems rather than fixing the basics. We don't seem to want to do that. Sometimes because it involves confrontation, and like most engineers, we don't like confrontation. But often it's easier to buy a toy. But if you go somewhere like the UK, they're quite interested in this, and certainly Australia is big on process and fixing processes, and that's quite interesting. And I spent some time in South Africa, and they're trying to remember why they were doing things, because the guys that built the processes have all left, which is a bit sad. Technology and tools are not a substitute for a robust process. So before you rush out and buy all the toys, make sure your process is strong, or at least it's growing and getting better, and it needs to be worked on. you need to add tools to look further forward. So I don't know about you guys, but I have vehicles in my family that are of various ages, and the older ones definitely don't see down the road far at night when it's dark. And I live in the country, and we have deer walking around, and that's a fairly serious risk. So, being able to get brighter headlights that look further down the road gives us more warning for issues, allows us to take evasive action and deal with those problems as they come. So add the tools to build the future view, and then automate the process. So one of the challenges is that, we get to be quite good at building a schedule. We build a schedule for the next week, and then the production manager says on Monday morning, yeah, everything's changed. And now we're running to market and we're doing this instead, and so on and so forth. So we need to really make sure that we're making good decisions and we follow the process. Last thing I want to leave you with is a takeaway that I built several years ago, longer than I remember. I remember doing Covey's 7 Habits, and this came up in there in terms of time. So I've converted his time management to maintenance management. So quadrant 1 is things that are important and urgent. And this is the stuff that we react to, unplanned reactive breakdown maintenance. Things that are not important but urgent in quadrant 3 are the wrong work and the rework. And then we've got things that are not urgent and not important, like doing the wrong PMs, which is why I talked about getting rid of the stuff that's in there that's a waste of time. And we want to spend our time in quadrant 2. So we want to have planned, preventive, predictive, proactive maintenance. And we have to spend more time here, but we're so busy in quadrant 1, we can't spend more time in quadrant 2. So how do we do that? Well, the way we do that is to start down here and eliminate the time we spent doing the wrong work and the rework and doing the wrong PMs. So clean out our PMs, write better plans, execute those better, and then the reactive work starts to go down and we can spend more time over here. So it's kind of a handy illustration. No disrespect to senior management, but sometimes we need a crayon drawing for senior management so that we can explain complex ideas and simple things in a simple way to them. And this has proven to be a very effective communication tool for me over 20 years here. And that's my presentation. So questions afterwards, I think after the next presentation, but we're done here. Thank you.
All right, Keith, thank you very much. Great presentation. We'll address questions at the end of Ricky's presentation. So next up is Ricky Smith. He's the Vice President of World Class Maintenance. He's a well-known maintenance and reliability advisor, consultant, and best practices educator. Ricky has over 30 years experience working as a maintenance reliability professional and is a certified maintenance and reliability professional, certified maintenance and reliability technician, and a certified reliability leader. So with that, Ricky, we'll turn it over to you.
All right, thank you very much. Hey, that last presentation was great. I really enjoyed it. That was perfect, spot on. By the way, who was it that works at used to work at Salt River? Who was that?
That's me. I work at Salt River, Ricky.
Yeah. So I was there probably 20 years ago.
All right.
It's been a while, man. Been a while. Yeah. Cool. Okay. Let's talk about the 8 steps to success in maintenance planning and scheduling. I'm going to keep this real simple because I think that's the way most people need it, because most organizations don't understand maintenance planning and scheduling, and they don't really see the value in it. And we understand that if we understand wrench time, and we'll talk about that. So let's take a poll here. How many people have effective maintenance planning? It's always my question. Can we take a poll with who's on the line right now with us?
We would have had to set that up ahead of time. Sorry about that, Ricky.
That's okay. But what I find is most people don't have effective maintenance planning. If they say they do, they don't really understand maintenance planning. And how many people kit or stage parts before scheduling? And we ask ourselves, why do we need to do all that? Well, if we look at utilization survey, this was one that was conducted a few years ago. This was on a crane crew at a company. So we look at what percentage of time the maintenance people looking for parts, and that was 25% of their time. Waiting on others, you're waiting on production to show up, or waiting on an operator, or waiting on your own maintenance technician, so 14%. Looking for tools. Oh man, I forgot to pick up that torque wrench, or I forgot to get this. Waiting on equipment. You know, you're standing there waiting on the equipment to shut down. Supposed to be down at 7 o'clock in the morning, but now it's 8 o'clock and we're still waiting for it. But they agreed on it last week, production did, that last week we would have this equipment down at 7 o'clock in the morning. Doesn't make sense. Looking for specifications. Okay, so what's the tension on the V-belt? What's the chain sag supposed to be? You know, what's the kind of clearance we should set on that bearing? All these things we need to know. It should be already in the planning queue, should have all this in place. Waiting on permits. You know, when we have the scheduling meeting should say that if you have somebody from operations has to be there at this time, they should show up exactly at that time, because in a meeting last week, they agreed that they would be there at 7 o'clock, but they're not showing up till 8 o'clock. And then waiting on a supervisor. We've all seen it. So what does that do? It takes away from the hands-on tool time or wrench time. No maintenance planning. You know, what is it? It's identifying the parts, tools, and procedures and standards, specifications required for effective maintenance work, increasing wrench time, that hands-on tool time. And, you know, planning is the key to success in precision maintenance. A lot of people talk about precision maintenance, but I tell you, the planning is critical to precision maintenance. In other words, doing things to specification. So planning and scheduling, some people so we do planning, but we do some scheduling too, but they're really two different functions, but they're dependent on each other. They're not just planning and scheduling, it's planning, scheduling, but they are dependent on each other. So I'm gonna give you my simple explanation of maintenance scheduling. You know, scheduling a maintenance, operations, contractors, engineering, and safety personnel to be in the right place at the right time for the right work, synchronized together, that's intended to minimize interruption to operation and production. You know, performing the right work at the right time. So, maintenance issues, you know, we talk about wrench time. You know, most maintenance staff only perform 2 to 4 hours of actual maintenance a day. What that means is that actual hands-on tool time is very low. So effective rec work is low, hands-on tool. And world-class wrench time is 55 to 65%. It's not at 100% because you got travel, you got breaks and all those things. But a lot of organizations get in their head that a maintenance person should be working 100% of the day. It's not logical. They may be chasing parts 100% of the day. Or they may be chasing for trying to find a supervisor most of the day, but that's it. So, and 70 to 80% of equipment failures are human induced. Yeah, we're full of error as humans because we don't know the specifications. Not having the right part at the right time. Just improperly handling and installing the bearings. You know, if we don't install parts correctly, how do we know how do we install it? Well, there's a best practice. And why don't we follow it? And this should be on the procedure. And what I like on the procedure, at each step, we have you initial beside each step saying that you did not miss a step. Because if you miss a step in a process or performed a substandard level, it creates defects known as failures. So having that step-by-step process is critical. I learned that when I went to work in 1980, went to work for a company, Alcoa Mount Holly. Was Alumax at the time. We had the first fully integrated CMMS in the world, and planning and scheduling was the hub of everything we did. I had no idea. I came from Exxon, okay? Little company, Exxon, had a refinery, but our planning and scheduling was nothing like Alcoa Mount Holly or Alumax. It was incredible, but I learned a lot. And I learned a lot about how do you do things the right way, because there you had to do it the right way, because we would lose a lot of money if we didn't. Alcoa Mount Holly became the first plant in the world ever certified as world-class maintenance. So that kind of set my foundation for proactive maintenance, you know, to this day. So a few known facts: schedule compliance, 80 to 90%. That's scheduled by day, by hour, 80 to 90%. Percentage of plan work. Plan work, you know, if you have a definition of plan work, it should be certain things that you have on there, you know, or their specifications, or the step-by-step instructions. If there are parts required, are they listed? And are they kitted? And so on. So so PMX, so schedule compliance, 80, 90%, 90% of plan work. PM execution, 15% of labor hours. The results from PM execution is 15% of labor hours. PDM execution is 15% of labor hours. We heard some of this in the previous presentation. And then results from PDM execution, you notice a lot of difference here. The PM execution was 15%. This is in labor hours. And the PDM execution is 35%. Most of our work should be coming from PDM, not PM. So, because preventive maintenance is inspect, adjust, lubricate. Inspection, yes, we're going to find stuff from it. But PDM's sole focus is to inspect. Wrench time, hands-on tool time, 18 to 30% typically. World-class companies, 55 to 65% is what most companies are. When I worked for Alcoa Mount Holly, we were at 55%, and they ultimately, when they became world-class, they were 65%. So maintenance costs, this is replacement of asset value, 19%. That's incredible. World-class, 1.7%. Alcoa Mount Holly, when they got certified as world-class, they were at 1.4% replacement asset value. If you want to know the definition of replacement asset value, the best thing to do, if you remember SMRP, it's Society for Maintenance and Reliability Professionals, download the SMRP glossary and look at the definition because it's very clear. So proactive work, where does it start at? It starts at PM and PDM. And then you could also say work request, but most of our work comes from PM and PDM. Then it goes to planning, goes to scheduling, work execution, work order closeout, and then failure reporting, analysis, and corrective action system. We understand most of that. This failure reporting is, if we close out the work order correctly, we should have data to tell us, or do we have failure patterns or failure threads that is consistent across our organization? And if we've got the right data, it's incredible what we can do about it because we can improve reliability. So, we'll say on the bottom, all this is proactive work, but without proper PM, PDM, proactive work is just not achievable. It's not going to happen. So what's a failure? Two types of failure. Functional failure, inability of an item or equipment performing it to meet a specified performance standard. We see that quite often. So the line is not running to specification. So we have a functional failure. A potential failure is an identifiable physical condition that indicates a functional failure is imminent. And I didn't put this on it, but it's usually identified through predictive or preventive maintenance inspections. Now, this came from Nolan and Heath study, Reliability Centered Maintenance in 1978. Also, the U.S. Department of Defense was involved in that study. So my question is, how does your organization define a failure? Right? This is where we need to make sure we have it clear, and you need to spell it out. This comes from SMRP, functional failure and potential failure. So I ask you, make sure you have a clear definition of a failure. Now, proactive planning and scheduling. Where does the work? When do you start planning? Well, you start planning when a defect has been identified. So the defects have been identified, as you see in here. So once we identify the defect, we go ahead and we plan it. So it said defect detected, work request initiated, work request received, converted to work order, job research and necessary parts identified, purchase rec entered and approved, parts ordered, job plan completed, parts received, parts kitted, work order released to scheduling, job scheduled, job completed, and never got close to failing. So as this equipment begins to deteriorate apart on that equipment, then we have time, if we do it right, if we see it early enough, we can plan it and schedule it. What happens if we don't have time to schedule it? The PF curve actually showed us it could fail before that because most failures are random. But what if you already had the work planned? It's already kitted. So if it does fail, then we know how long it's going to take. We got the parts kitted. We got everything ready. We got the procedures. It makes life a lot easier and repeatable. So where do you start? Okay. Step one, identify external distractors, poor spare parts and inventory control, If you have a storeroom right now that's free stock, in other words, people can go in anytime they want, you got a problem. You got to have controls over those spare parts. All parts has to be checked out and charged to an asset, unless the parts are not assigned to an asset, like a broom. Okay, but all parts must be checked out and charged to an asset. Conflicting ideas of what planning is. People get confused sometimes. That's okay, but we need to have a clear definition of it. Planners taken off the job, put on tools, or involved in daily activities, part chasing, facilitating daily work. We don't want them to be pulled off. I mean, we don't want planners involved in this week's work. They're working on future work, next week's work, not this week's work. That's already been taken care of. That's past. Maintenance and production not acting as a team. Pointing fingers at each other. I know when I was a maintenance supervisor and maintenance manager, we had that. Okay, so I got it. All right. No planning process, unclear expectations, unclear roles and responsibilities. RACI charts, roles and responsibilities. It's critical to defining that. And I like to use RACI charts. Who's responsible? That could be multiple people for a step in the process. Accountable, the buck stops here. Only one person can be accountable. Consulted can be many people. It's two-way communication. Informed, it's one-way communication. I send you an email, no reply accepted or expected. Okay. Maintenance leadership's not following the plan. Hey, we got to pull off of this and do this over here. But if it's a priority one job, why do we pull off this job to go do another? It doesn't make sense. Planning and scheduling and management approve of that scheduling, then it should follow the process. Emergency urgent work's too high. You're going to have to restore the assets. And people ask me, so which asset do I start with? Well, if you're reactive, it doesn't matter which one you start at. But I would say it's the bottleneck. Which one do you think is the worst performing actor? That's the one I want to start at first. Lack of discipline. Everybody does what they think they need to do. So, hey, I've been changing V-belts for 20 years. Yeah, I know how to do that. Well, that's why you change a lot of V-belts, because you don't know how to do it. Okay, you don't roll it on the shiv, and you don't over retension the belt. When a belt when it starts to lose the flexibility in it, it starts to drop. So when it starts getting loose, it's slipping. That means the RPM speed of whatever you're driving is not meeting expectations. So the best thing to do when it starts to fail is that we want to cut the belts off, put new ones on it, not roll them on the shiv either. Maintenance leadership not following the plan. Many times that happens. Emergency urgent work too high. Lack of discipline. It all comes down to culture change. We got to change the culture. Educate the team. I'm talking about coaches, not just for planners anymore. It's for everybody. Plan operations, leadership, frontline operations leadership, maintenance and reliability leadership at all levels. Then we need to be educated. What is true maintenance planning and scheduling? And what do we agree on our plan and how it's going to be, how it's going to be mapped out? Planners need to be educated. They need to go to planning and scheduling formal training, not be taught by somebody else. They need to have the formal training. And I'd say send your people to the same company over and over again to get that maintenance planning training, so they all speak the same language and they all hear the same words. And operators, we want to educate them as well. One of the things I use a lot, toolbox talks, as I call them, educate them. If you go to my website, and I'll share with you later what it is, but I've got toolbox talks on maintenance planning and scheduling and so on. The single point lessons is all they are. And what I do is I tell people what I've used in the past. We'll go up when I'm working with a plant. We'll post like one of them, let's say effective work procedures. Okay, so we're trying to get people bought into it. So we post it on the bulletin board, and everybody looks at it and they come ask the question to maintenance leadership, say, what's that all about? We'll talk about it later. What? And then come back to maintenance, supervision again. When are we going to talk about it? We'll talk about it later. What you're trying to do is start a conversation, or maybe people start talking about, what does that really mean? Does that mean somebody's going to start getting fired because we don't do something right, or what? I don't understand it. Or this guy that came in as a consultant, didn't know what the heck he's doing. Now he's telling us to do something different. The toolbox talks change the world. Believe me. Developing a RACI chart. I mentioned that earlier. RACI charts defining roles and responsibilities for maintenance planning, but also maintenance scheduling. You know, who's accountable? That's one person. The buck stops here. Or, you notice on the left, I got all the tasks. So PM, PDM executed a standard, job scope, repeatable corrective work procedures, parts ordered, kitted, and then work executed a standard. You know, responsible can be multiple people. All this does is allows us to align everyone's thinking. So everyone's focused on the same thing. Develop guiding principles for planning. You know, the planner should focus on future work and maintain at least 2 weeks of work backlog that is planned, approved, and ready to schedule and execute. The reason why I want backlog is if we have an unexpected failure or outage, we can pull that out and we can go do the work rather than say, what are we going to do now? Planners do not chase parts for jobs in progress. One of the things I tell people, how do you know if you got a proactive planner? Call your planner on the phone and say, hey, I need a part right now. The next thing you hear should be the dial tone. If you hear the dial tone, you got a proactive planner. Planners do not chase parts for jobs in progress. You know, supervisor, crew they handle those problems. Scheduling does not occur until the parts are kitted. They're kitted. In other words, they're in a secure area. And then we will maintain a stable, non-fluid criticality index. Asset criticality, defect severity is how do you schedule work. Asset criticality should have a ranking. And some companies, when I worked at Mount Holly, we had a ranking between 0 and I think it was, I can't remember, 400, 500, something like that. Some places have 0 to 3 or 0 to 4. The more granular you get, the better it works. And then, you know, we will improve wrench time through cooperation with everyone. So if we develop guiding principles with production and the maintenance techs, especially the ones that influence people, it will help us a lot. So wrench time, what is wrench time? It's hands-on tool time. Okay, and I mentioned it before, but hands-on tool time is actually when someone has a wrench in their hand. World class, I mentioned before, is 55 to 65%. The wrench time studies I've done, a lot of them, I said highest percentage of them, we're lucky if they were at 20 to 30%. So how will you increase my maintenance effectiveness? You got to know what you don't know, you know? So how do you conduct a wrench time study? Again, there's ways of doing it. There's stuff on the internet. You can find these things like here, it said waiting on operations. So what you do is you take a snapshot. Okay, so you just walk out and you say, okay, so what people, maintenance people stand around and wait on operations. Was it 5 minutes, 10 minutes, 15 minutes? You just check it and go. They used to have wrench time PDAs that you could rent and you could use those. And I know a company right now working on a PDA for that wrench time app for your phone. That way you can do a wrench time study. It's not to talk about anybody. It's not to point fingers, not to put down names. It's trying to improve a process. That's what it's all about. Define your planning process. You know, here I've got, you know, identified, this is the planning workflow and work identification. I've got the, what I call swim lanes. So you have your maintenance technician, storeroom clerk, maintenance planner, and then whoever does the requesting of the plan work. Intercept ranking, kind of interesting concept, you know, prioritize work to be planned. How do you know? You could do, like I said before, asset criticality, defect severity. How severity is the problem? How quickly will it fail? If it's a bearing, good luck with that one. So intercept ranking basically it's just a model that if you've got the information from your CMMS, that you could put this into an algorithm and it could rank everything down from first to 20th in this case. So you got severity, see it changes. You got severity 1 high, all the way down to the bottom even. But you notice the order is different. It's all because of defect severity and asset criticality. Develop effective, repeatable procedures. Without repeatable procedures, you're lost. It's like being stuck in the ocean, you know, and you got no map, or you fall, or you parachute out of a plane, you don't know where you're at, and you don't have a GPS. Good luck with that. You know, developing effective work procedures are important because if you've proven something works one time, why don't we repeat it? So the worst thing could happen is we do it again. Remember, we're talking about human error. Human error is high. So we're developing these procedures. We want a repeatable process. We want to capture knowledge from previously performed work and previous failures too. Train new employees. How do you train a new employee? Well, hang out with Jimmy. Well, okay. So how much information can Jimmy share with them? I mean, there's nothing wrong. I mean, it's good to have someone work with someone, but it's best to have a procedure step by step. I do have a template that I can share with you. So, and you'll see my email address at the end. I'll be glad to share it with you. But it's a template where you can put the procedures in there step by step, and it'll help you a lot. Use these repeatable procedures to train new employees. What's the best way to train them? Say, here, this is our procedure for checking this or whatever that is. And then it reduces human-induced failures. You know, the whole thing is about variation. Variation is a deadly killer to our asset reliability. So step 8, measure effectiveness. Percentage of work orders planned. Is it trending up, trending down? Is it got a curve shape? You know, it's just out of control or what? Percentage of planned work, 90%. So proactive, 90%, reactive, 2%, required no planning, about 8%. This is world-class. Percentage of work orders with estimated to actual work hours. It's an estimate, okay? A lot of people take it as exactly how long it takes. It's an estimate, plus or minus 10%. Without a repeatable procedure, by the way, you won't get that. Backlog is measured in labor hours by week. Ready to schedule work orders, 2 to 4 weeks of backlog. Okay, so what's 1 week of backlog? If you have 10 maintenance people times 40 hours, so it's 10 times 40. Okay, that's 400 labor hours of backlog. Total backlog, 6 to 8 weeks. Total backlog is just the numbers of work orders, okay? Because every work order is not equal. And then the percentage of work orders with comments and recommendations. At the end of a PM work or corrective maintenance work, at the end, it should say condition is found in the asset, condition is left, any recommendations, changes to the procedures. Then PM compliance, you know, critical assets, 100%. You know, not all your assets are critical. If you rank from 0 to 10, I say the first, 20% of them, maybe your most critical, or 10%. It depends on how you rank asset criticality. You know, and Peter Drucker said, if you can't measure it, you can't manage it. And that's so true. Put together this planning and scheduling dashboard. I like to have it where people can see it. You know, I like to put it out so everybody can see it. So you see the far left, 90%, which is our percentage of work orders with procedures and specifications for this week. Stock out, 73% of stock out. Stock out is when you go to the storeroom, the computer says it's in stock and it's not there. Probably never happened to any of you. I see it quite often. Planned work, it's all in definition, 24%. Schedule compliance by day, by hour, 33%. Emergency urgent labor hours, 68%. Wow, that's a lot. Maintenance cost compliance, 23%. So you can't measure it, you can't measure it, you can't manage it. All right. So what is maintenance planning and scheduling is a team effort, requires everyone participating. It's like pulling an elephant. I always say, if you try to pull an elephant by yourself, you'll never pull it. But if you get everyone on that same rope and pull it, you can pull it. So planning and scheduling is a team effort. It requires everybody's hands on that rope to pull it in order to have success. So I'm recommending you lay out a plan to optimize planning and scheduling, keep it short and to the point, make it attainable, make it measurable, ensure alignment is transparent. Okay, but the day to start a journey is today, okay, after you have the plan. All right. So questions, there's my email address, my website. There's some toolbox talks on there about planning and scheduling and a lot of other ones too. You don't have to use the email address or anything in there to download anything. It's all free. And then you can join me for my PM Best Practices 3-day workshop. If you send me an email, I'll give you more information about it. It's virtual and it's also live. So you get a choice to come live. That's where I'll be presenting, but it'll be transmitted throughout the world. So anyway, I'm finished. Hope you have a good day. Hope to hear from you. Thank you. Goodbye.
Thank you, Ricky. Appreciate your presentation, and thanks again to Keith. We do have a couple minutes here, and I wanted to kind of throw a couple things out to both of you. One thing you showed on yours, Keith, was your schedule for let's see, next week, and you had it 100% loaded. I'm curious on reactive maintenance activities. How do you handle break-ins when you're 100% scheduled like that?
So I think you have to make some decisions about, are we going to do this or not? And the first question I like to ask is, do we need to do this today, or can we plan to do it tomorrow? Because I think a lot of reactive work is artificially excited. We get really anxious about it, but really, if you think about it, we don't really need to do half that shit every day.
Yeah.
The other thing to do then, with the other advantage of having a full schedule, is you can have a grown-up conversation about, okay, if you want me to do this 2-hour job with 4 guys, then which of these other jobs are we going to take off the schedule?
Yeah.
And then that drives the overtime discussion and the authorization, because now we can turn around to the plant manager and say, Jim, we need to spend some extra money today to get all this stuff done, and because it all needs to be done. And I think the trap with 80% scheduling is that you think you've got time to do everything, and you just kind of do it, and you don't have those discussions about managing your schedule. So you don't manage it, you just add the extra work, and then you become more reactive, and the schedule starts to fall apart. And the end of the week, you got half of it done and not all of it. So,
Yeah, I think it's a great point. I've had people ask me, say, how much long is it going to take on the job? And, I said, well, the job is scheduled for 8 hours. Yeah, but can you cut it shorter? Okay, tell me what you don't want me to do, the specification. What is it you don't want me to do? Here's a list of things we're doing. So tell me what you want to cut out. No, we still want it all done. Okay. Like I did with the production manager at one plant. Him and I always had a little short conflict here and there. But he would tell me, no, I want this work done, but you're going to have half the time that you schedule it for. And I want it done right. I said, let me explain something to you. There's 2 ways we work. We either do it right or we do it wrong. So you got a choice. You tell me which way you want it. You want it right or you want it wrong? And we finally got it worked through, but don't do that. Anybody there don't. Okay.
I think too, it comes. Sorry, Ricky.
Office. Okay.
Yeah, it ends up being a business decision too. And one of the things we don't do well as maintenance guys is talk about business. But the same vice president that I mentioned before, that I got into a bit of a fight with about the belt repair, he decided to cut a week out of a turnaround. And so, you talk about turnaround planning. So we got sneaky. What we did was we tracked all of the equipment for 6 months that did not get worked on. And we added up the cost of failure for that equipment. And it turned out to be 5 times what we saved in that extra week of production. And I put that in front of the VP and said, here. He said, yeah, I know. But we needed the product, and it was a business decision. We knew we were going to run the risk. I said, that's fine. But the data, you need to have the data to have that discussion too. So sometimes you do stop work. You do take the schedule apart because that's the right business decision to make. But we need to make it a business decision and not an emotional maintenance versus operations decision.
That's a good point. Operations always generally seems to want the all the equipment fixed right now, and that discussion is sometimes a contentious discussion to have. But I think it's a good point to have those discussions. So we have time for one more question. I'm going to kind of throw this out to Ricky, you first, and you talked about changing culture. And I think with a lot of this planning and stuff like that, you end up with a lot of, this is how we've always done it before. Any tips or suggestions on how to facilitate that discussion and make that a smoother transition into a more process-oriented maintenance planning strategy?
Okay, let me jump in because we might have lost Ricky. So yeah, you're absolutely right. The big issue with this stuff is culture change. And the big issue with the culture change side of, we can build a good business process, but we need to change the way we do things. And people need to understand what's in it for me. Because in the end, we're motivated by, how is this going to make my life better? So if we can turn around to the production guys and say, look, if you commit to executing the schedule as we agree to, and you commit to telling us what's important to you, then your equipment will be available on a little run when you need it to run. and we can do that. Now, when we say we've got a problem, you need to listen to us, and we need to explain how that's going to work, and we'll give you an option on how long it's going to take and so forth. But that then needs to be a dialogue. So, communicate why, communicate the what's in it for me, what does the future state look like? All of that stuff that we do as culture change is really important. Because otherwise you build a business process and people say, well, this is stupid, I can't make a decision with this. So,
or worse, malicious compliance, right?
Absolutely, yeah.
So that's a good point. The communication is the key in all this, and we're gonna go ahead and wrap it up there. So I do appreciate everybody's attendance here. Keith and Ricky, great presentations. Thank you for the information. I hope everybody out there is being safe, and I'm gonna kick it back over to Kim.
Thank you, Hank. Appreciate everyone's time today. These were some excellent presentations, so we do appreciate that, and some really great content. And we want to thank our sponsor again, NRG Energy Services, for sponsoring this session. We truly appreciate that, and we hope that you network with one another while in between sessions. The next session will start in 15 minutes, so we'll see you back again in about 15 minutes. Thank you so much. Everybody have a great day.